Hello, everyone. My name is Jeff Peters. Welcome to What is and How to Develop an AWS Architecture. So this webinar has some relatively straightforward goals, to be absolutely honest. We're going to start off with just looking at the building blocks of an IT architecture. Now, that's a pretty broad spectrum of possibilities when we say we're going to define an IT architecture, because that could range from a friend who says, I have the best new app. I'm going to need a web server to be able to produce that, all the way up to a multi-million-dollar organization with a global reach. The thing is, when you're using AWS, Amazon Web Services, to provide this architecture, you're going to find that you have the ability to be flexible, to meet anything of any range between those levels to use this. We'll go through and also look at saying, listen, there are a number of cloud providers out there. Why should I use AWS? Well, when we're working with these, we're going to see those different spectrums of possibilities that we mentioned and how to be able to get the benefits of using AWS out of this. And then finally, where we're going to spend the majority of our time is going through and looking at some of the different services, 3 specifically, that will be required to build any IT infrastructure and how to be able to use them to your advantage to be able to say, listen, this is going to be a really, really powerful tool. How can I use AWS to be able to make that happen? So, okay, let's jump right into it. We're talking about these architectural building blocks in using this. Now, first of all, let's be really clear. When I'm using these, there are going to be, for pretty much any architecture that's built, 3 major areas. And we start almost always with storage. Now, storage is really simple, right? I need hard drives. What's so exciting about that? Well, the truth is, this is one of the things that frustrates people in a local data center more than just about anything else. Asking for additional space on the SAN to be able to have access to storage that's necessary to be able to build a dev environment or anything like that, it's a constant process. What if we had the ability to be able to say, at our disposal, at pretty much any moment, with very, very little preparation, I can have unlimited storage? Oh, sounds great. Now, admittedly, you pay for what you use when you move to the cloud, but you'll see the benefits of using this. But once again, we're not even talking about the cloud yet. We're looking at this from the point of view of a general architecture and what are we going to need? So storage, sure. I need a place to put stuff. This could just be your file server. This could be the hard drives that are attached to your servers that are running operating systems and applications that you'll need for everything else. Log files need to be placed somewhere. Things need to be archived long-term for compliance, regulatory, or just backup and disaster recovery reasons. I'll need storage in doing that. Okay, we're going to need computing power. Well, no joke, right? I need servers. But when we're working with this is going to fall under so many different categories at this point. It could be just your basic virtual machine. These are available everywhere, right? Once again, we will be looking at this from a cloud perspective and how much easier it is to be able to spin these up and get them running, but compute's going to be a necessary concern here. And then finally, we're going to need the tool that ties all of these things together, a network. This could be something where you picture a simple VPN from your house or organization into the cloud. It could be literally connectivity between servers and using these. We're going to be looking at these things as the 3 pillars of pretty much any IT architecture that's going to be generated in using this. Now, like I said, we're starting with just the basics here. But the question will then come up, what's the benefit of using AWS? Because you really do have to ask, because I get all excited about this and I really start talking about technology and I love it, but there does have to be a question answered. And that is literally, what's in it for you, right? Let's be mercenary about this. So we start off by understanding that this is cloud-based. And once again, I need to clarify really what that means in using something like this. There is a big difference between building something on-prem and building something in the cloud. Now, realistically, there's no difference. And you're like, Jeff, you're kind of going back and forth and saying the same thing 2 different ways. But what I mean by that is everybody hears the cloud, and I'm using air quotes that you can't see right now. And then they point up at the sky and say, yeah, that's where I'm storing my stuff, or that's where my computing takes place. But realistically, the cloud can be described extremely easily. Someone else is handling the hardware for you. That's it. Everything else is basically the same in the cloud. When I start talking about Amazon Web Services, now let's be clear, there are a lot of benefits to them actually providing that hardware for us and using these. We'll talk about ease of use, particularly when we start getting into some of the services that I've already mentioned, storage, compute, et cetera, and using these. But the fact that I get so much of my focus back by not having to worry about hardware from that perspective is such a big deal in using these. Additionally, AWS is spread worldwide. Now, when I say 24 regions, this means that they have data centers, multiple data centers in each of 24 regions, and they're growing constantly and using something like this. When you look at their global presence, and they have a nice little chart that'll show this to you, you'll see that, even if you're just focused on North America, we have the combination of certainly East Coast, West Coast, centralized, et cetera, as well as GovCloud. Now, GovClouds are only for the United States, but it does give a higher level of protection for government agencies internally in using this. But maybe you're looking to expand, or you already have expanded past North America, or just aren't here. You can see that their global reach is pretty impressive in using something like this. With all of these different regions, understand that I could be anywhere in this region, right? I could be sitting here, I don't know, somewhere in the United States, and could I launch a new virtual machine in Tokyo at a moment's notice? Absolutely, right? You don't have to be where you want to launch your entire infrastructure. Can you spread it across multiple regions for higher levels of availability? Absolutely. And once again, you pay only for what you actually produce and use in doing these things out there. So pretty solid tools in using these. Now, when we start talking about architectures, once again, understand that we can start at a very basic level, meaning they can be extremely similar to what you'll do in your own data center. In fact, I would say most of my clients from a consulting basis are going to look at what's called a lift and shift as their first actually order of business. And what that'll mean is they'll say, okay, here's our headquarters or whatever we happen to be using. And out here, that's not popcorn, that's the AWS cloud. I'd like to be able to take what we have here and be able to move it there in doing so. So whether that means I've got 2 servers, let's keep it simple, and I move 2 servers up here, I can certainly do that. Now, the truth is this lift and shift is extremely easy to implement because all you're doing is picking up where it is and literally moving it to someone else's hardware, which by the way means I don't have to worry about the physical security of my own data center. I have unlimited growth capabilities. There are all sorts of benefits with that by itself. But in reality, what we'll start to find is that as we start to develop these applications, as we start to get more and more what they call cloud native in using this, meaning it's been designed to take advantage of the cloud, we will see other benefits as well. We will see reductions in cost. We will see improvements in automation, all sorts of benefits of using an AWS or cloud-based architecture and using that. Now, when I go through and I start saying, okay, right, so what are the benefits of using something like this? Let's go over it from a business point of view. Because once again, we've got to look at this from the what's in it for me, not just, ooh, AWS sounds interesting and look, I'm in the cloud, right? It can't be that basic in using something like this. So let's start off with focus on business needs instead of infrastructure. So multiple times I have been in an organization where I've been required to implement something in IT, right? That's very broad, but let's say a database, a web server, anything like that and using these. And while they start talking about this, I'll admit at that point, a portion of my brain is immediately going to say, okay, quietly, internally, most times with these conversations, I'm going to say, well, all right, do I have enough bandwidth? Do we have a server rack that will handle this? I wonder if we have enough storage space on the SAN. What type of processor are they going to need? I wonder how many users will be accessing this simultaneously. Because the answer to all of those questions are going to determine things like, do I need to buy additional hardware? Do I need to look for additional bandwidth? Are we going to have to take away from something else? Or what if a large number of people, more than what I expected, jump in and have this? If I could take those needs off of my brain, right, out of my actual hands, which is exactly what you do by going to a cloud infrastructure basis, right? All of a sudden, my focus can be on how do I make this website better for the end user? How do I improve the user experience? How do I actually improve the queries so they run faster against my database? All sorts of different operations can be used. The next, spend less money. Now, I felt absolutely obligated to put in parentheses, if designed properly. Let me be clear. There is no guarantee that if you move to the cloud, you will instantly save money. In fact, Without proper planning, it'll probably be the exact opposite. If you design properly, you're going to use only what you need. And here's the thing about the cloud. Generally speaking, if I'm in AWS and I turn something off, I stop paying for it. If I need more, I pay a little bit more. If I need less, I pay a little bit less. And it's a scale that instead of basically a culture where every time that I need additional something, so let's say here is our level of need that over time, right, will increase and change as it goes through this, right? So here's going to be our need for this. Normally what that means is I will go ahead and purchase, right, something that's going to allow me to be able to continue to be able to meet that demand. See, the idea is if this is the demand, the red line is demand, what will happen is at each of these little stair steps, I'll make an expenditure to be able to meet additional demand, to be able to get up to that point, to be able to use this. Well, what if you start to notice, oh gosh, this is all well and good as long as this continues to go up. But what if in reality, I've got more of a demand that goes like this, right? Up and down. Not on a month-to-month basis, but on a day-to-day basis. Is it possible to be able to say, well, during the day when we're very busy, I spend more, but during the night when it's not busy at all, I can spend less by turning things off? Yes, if you design them properly in the cloud. Additionally, these changes can be made so quickly. The agility of working in the cloud is ridiculous comparatively. In my experience, I would say that the average organization normally has, in terms of time to be able to get a new piece of hardware, 6 to 8 week time period, right? From the time where I say I need it, I've requisitioned it, it's been authorized, it's been shipped, it's been delivered, I go ahead and complete the entire operation for getting it up and running, and then it's in service, like I said, average 6 to 8 weeks. And there are organizations that I've dealt with that have been more on the year-long cycle in using these. Now, some people will say, well, Jeff, wait a second, I can do that with virtual machines internally. You're right, you can, but you've already paid for the hardware that would allow that to happen. In AWS and Amazon Web Services, I don't pay a penny until I turn it on and start using it. That's a big difference. When I say I need a virtual machine, you're right. On your local data center, can you have an engineer turn a new virtual machine on? Yes, but only if long in advance someone paid for the hardware to be able to handle this. I'm talking about a situation in the cloud where I decide I want it, I haven't paid a penny yet, and within minutes I have it up and running, and only then do I start paying for it. And if I decide I don't like it, I turn it off and I stop paying for it inside there. Big differences in terms of using something like that. Now, once again, I mentioned the global presence of AWS, and I showed you the 24 regions, and look what a global reach, but I really want to make it clear once again. As an organization gets larger, a couple of things are going to be important, at least with a global reach in using this. One is I'm going to want to reduce latency for all of my end users. If all of my servers are in one location, but my users are spread across the world, people who are farther away are going to see latency. They're going to see lag. Nobody likes lag. How do I decrease that? What if I put some of my servers near them at no additional cost? If I've got 10 servers and some of them are in the United States and some of them are in Paris, is there a big difference to me? No. If on the other hand, I'm a normal non-cloud organization and I say, I want to launch some servers in Paris, does that mean that I'm going to build a data center over there to be able to handle something like that? That would be a crazy expense. It's so easy to be able to take advantage of AWS's reach as a partner and using that. So like I said, we're going to spend just a little bit of time, like we just did, going through and looking at the benefits of working in AWS and the cloud specifically. But I really do want to focus on some of the capabilities and responsibilities, I guess, of these different components for any IT infrastructure. And as I said earlier, we're going to start off with storage. Now let's start off with your responsibilities in using something like this, right? When I go through and look at this, and I'm looking at the responsibility for high availability and capacity planning, we've got to understand that that's in your own data center, right? Which is hardware-based. You're purchasing the hardware using these. I have a number of different pieces available. Hard drive, storage area networks, all of these things are there, but listen, it's not just that it's my responsibility to buy them. I have to configure them. I have to be able to make sure that they're set up properly. I have to make sure that I have enough in doing so. Once again, this is an example of removing that focus from your basically needs as opposed to just infrastructure planning in doing these. In AWS, which is more service-based, where I'm saying, I'm not going to worry about the hardware. AWS will handle that for us. We can use tools like the Simple Storage Service, S3. And I'll show you an example of this in just a little bit. First things first, when we talk about storage, the number one goal is to make sure that none of my stuff gets lost. You never want to lose data. It's ridiculously difficult to replace without things inside to be able to make it work. So when we look at things like redundancy, right? You'll hear terms like RAID and other things along those lines, but honestly, what if you didn't have to worry about that because they are built in? When we talk about the Simple Storage Service, S3, and this is like the most basic building block of AWS. This is where somebody says, I need to put some stuff in the cloud. S3 at your service. Unlimited capacity is mentioned, meaning literally you can just keep adding stuff, and as long as the check doesn't bounce, you can continue to add more and more and more. And it's also super cheap in using these. We'll get into that here in a second. But unlimited capacity with redundancy built in. And when I mean redundancy, we're going to see just how extreme that is in the way they set this up. So as promised, S3 is going to be our major tool. If we look at the console for working with this, right? It's an easy, so this is the AWS console where you would do all of your work, at least from a graphical perspective, to use these. And the services that are available to you are pretty broad, but we're going to jump right into S3 here and using this. And I'll come back and actually demonstrate a lot of this information, but this is our S3 service and using these. When we use this, the idea behind it is really easy. It is cheap and it is unlimited in terms of storage. And I mean, when I say cheap, I mean a couple of pennies per gigabyte per month in terms of storage, right? And when I say unlimited, there is a small limitation. A single object, a single file can be no more than 5 terabytes in size, which generally not going to be a major issue for most people out there, but it does have unlimited storage and it is relatively cheap. Now, this also goes back to paying for what you use. Let's say you store a massive object up there, right? Terabyte after terabyte after terabyte, and you keep it up there for a few months. When you realize you don't need it anymore and delete it, you stop paying for that storage. This is the difference. You're not paying to provision, to buy all of these hard drives. You're saying, what did I use? Okay, that's how much I'm going to pay. I use less next month, I pay less next month. I use more, well, you pay more. But the idea behind it is still paying for what you use in doing so. Now, internet accessible but private by default. This is an issue that many people run into when they first hear about the cloud. The general idea of, I'm not putting my stuff up there because anyone can access stuff on the internet is completely and utterly wrong in using this. When I talk about it being internet accessible, everything in S3, every object that you upload does get its own web address, meaning if you have permissions, there's the private by default portion that I just mentioned inside here. If you have permissions, you do have the ability to access it. But guess what? By default, only the owner has permissions to access this. So while the internet is the standard tool for accessing information in S3, it's basically to say it's not opening it up to everyone to be able to access this information. It is internet accessible, but not publicly accessible by default and using that. Now, the additional features that are available here, I can encrypt things. So even if I'm still worried about permissions, someone's going to get public access to this, I can still encrypt my data and protect it further. Remember I talked about I have to worry about durability, basically saying, well, listen, now that I've offloaded the responsibility to handle the hardware and handle the redundancies to AWS, should I trust them? What's the SLA? What is going to be the acceptable level in using something like this? Well, when they bust out and say, hey, listen, we're going to offer you 11 nines of durability, as in, I would almost guarantee it's more likely that you're going to get hit by lightning in your lifetime than it is that you will lose a file in S3. All of a sudden you say, okay, that's building a little bit of trust. And that's one of the big aspects of the cloud that people have to get comfortable with. Being able to look at and say, okay, I trust a cloud provider, Amazon Web Services, to be able to dependably guarantee this level of service in using these things. Now, S3 has additional features, one of which is a little surprising when you first see this, because it's just storage. Static website hosting? Yeah, and it's super easy to implement which is a really cool little aspect of using this. A number of small businesses use this on a regular basis to have a ridiculously inexpensive small website hosted there and using these things. Now I'm going to open up S3. I'm going to show you around inside. We're going to create a bucket, which is kind of the standard unit of actually holding this information. Upload a few files. Well, I'll show you how to encrypt them. We'll even create that basic website that I mentioned that you might want to be able to see in using something like this, right? So we get a number of different tools within this, but it does give us the ability to be able to manage them a little bit more easily in using these things. We'll go through and actually see a number of those different tools out there. I've already got it open over here. So let me go ahead and open up our S3 management console. Once again, I've logged in as my own account. Here's my Jeff account inside of AWS. I'm in the S3 section in using this. Now, let me be clear. I mean, there are a lot of services available. I just clicked on the little services icon up here at the top, and you can see just how many are available out here. We're sticking with the basics, S3, EC2. I'm going to show you VPC, Virtual Private Cloud, here in a little bit as well. But for right now, we are in S3. Now, let's say you don't have anything, because to start with, you haven't created a single thing. You hit Create Bucket, and you're going to see just how difficult this is to be able to generate a bucket in doing so. So let's go ahead and say this is a GK-webinar-test inside in some way, shape, or form, right? And I hit Create. Congratulations, you have made your bucket. This is now where I can upload information into it to be able to have everything done extremely easily. Now, having said that, I created this. I've got the information inside, or I got the ability to modify it, but that's just obviously the basics. There are other properties that I'll be going through, versioning to be able to keep duplicate copies of something. I mentioned the static website hosting and encryption, and even more things down here as well to be able to use these. But for the basics now, really, really, really easy to implement in doing so. All right, so now what we have is this basic bucket. And let's just upload a simple file into this to be able to use them. All right, so, oops, sorry. Let me jump back in there. I hit upload. Now, all I could do is I could browse to the files, but I happen to have a logo of some of the things available out there to be able to use this. This is available, so I'm going to jump right into this, and I will drag a file right into there. Now, it says architecture logo is what this says, and I hit upload. Like I said, they make it really easy, and if you've used other tools that are web-based, this is not difficult to understand out there to do this. So, okay, let me show you around inside, because again, with storage being a solid building block of ours, how do we actually utilize this? This is your file server in the cloud, right? Really basic file server in the cloud. And you can put, as I mentioned, millions, even billions of objects in a bucket if you want to. Okay. Now, when I use this, I've uploaded the file. Now, normally I go to a file server, I click on it, it opens, right? But all of a sudden I'm getting generally what's known as metadata, information about my file. It didn't open. You're right. And then I look down here at the bottom, and it says you've got an object URL. So this is the actual address that this will be there. You can see it has an HTTP address. I'll zoom in real quick so you can see it a little better. GK-webinar-test, that's the bucket that we created. And at the end, architecture logo.jpg that we generated here to see that. Now, if I click on this, actually I just say open link in new tab, and it pops up, I'm going to get this access denied. And this is exactly what I meant by the fact that even if, yes, everything gets its own URL, it doesn't mean that everyone can access that data. There's no way. Access denied in doing so. So what if I did want it to be available to everybody, though? Can I do that? Well, you can, but let me be clear. There's not going to be an, oops, I accidentally made that public. In fact, if you can look real closely here, you're going to see that the make public bucket button is actually grayed out at the moment in using these. Now, if I'm inside of this, does that mean I can't view my picture? No, there's an open button. And I'm in the section, in the console. I can see it. I can open it. I have permissions. I'm the owner. I can see that. But if I try and use the URL, even I, as the owner, says, no, you have access denied to be able to do that. So how would we go about making this accessible in doing so? Once again, pretty easy if you know what you're doing. So I'm going to scroll up and I'm going to click on Amazon S3 and I'm going to find my bucket here, GK Webinar Test. I check the box for it and I'm going to say, edit public access settings. I mean, you can even see if you actually close this for a second, there's a section, bucket and objects not public here on the right. Edit public access settings. And again, you have to know, you uncheck the box save. And even then they're saying, hey, are you sure you want to do this? You literally have to type in the word confirm. That is not something where you go, oops, my finger slipped on the mouse, I clicked on something, I made it public, whoopsie. No, right? You're going to have to confirm this. Even then, I have made the bucket capable of being public. But if I refresh the page again, it says, no, access denied still. In addition to making the bucket public capable, I have to go to the particular object and make it public. Now, once I've done that, and again, it gives me a warning, are you sure? Everyone will have access to this, and I say make public. Then I go to my page and I say, okay, I refresh it and boom, instantly accessible worldwide to whomever would like to access this. The point is that it is still private by default whenever I access something like that. Okay. Now, once again, if I wanted to be able to do more with this, as I said, I can click on it and I can see any kind of encryption. It says none. Well, let's see how difficult that is. Well, I could go to properties, encryption, and encrypt it. Standard AES 256. That's pretty much what Amazon uses for just about everything out there. Save it, poof, it's been encrypted inside there to be able to use this, right? Pretty straightforward in terms of using this. If I go back to my overview, all of a sudden, yep, instantly encrypted and doing something like that. Okay. I mean, pretty easy. By the way, can I also go to the bucket properties, encrypt that so that everything is added to the bucket will be encrypted automatically? Yes, of course, in doing so. Let me actually go in and decrypt that real quick. I don't need that to be encrypted at this point. Save that, make the change inside there. Simple enough to be able to use these. Now, having said that, it may take, nope, it's pretty quick. It'll actually go back. Sometimes it'll take a little time for the encryption to go away, but very, very quickly in most cases. All right, let's go back to our bucket. I'm going to upload another file inside here. Now, this file is a little bit different. Actually, let me go ahead. I'll show you what it looks like inside here. I'm going to go ahead and edit this. And I'll show you, it's just a really simple website here, right? Literally, if you've ever used HTML, I'm not showing any kind of programming prowess here. This is an extremely basic web page. I mean, I labeled it that for a reason. That literally just says, hello world, and points to my architecture logo.jpg inside there. That's it, right? So simple, simple, simple file in using this. But in doing that, I'm going to go ahead and upload that file, that index.html inside there to use this and upload it. It's there. I will need to be able to make this public as well, right? It's not automatically made public the way I've set it up. And then I go ahead and click on this. And now, right now, can I have a little object URL that I can click on it and I can see this? I can. But that's not really a website because you have to know the exact address and this and that and the other to do so. This is where going to properties of your actual bucket can actually help. So I go to the properties, I find static website hosting. And literally what I'm going to do is simply say, yeah, I want to use this bucket to host a website. I put in the name of the file that I uploaded, index.html. I hit save. That's it. I now have this website, GK webinar test, etc. When I click on it, it brings up the site. Now, it's a static website. Once again, I'm not saying this thing is going to be something that will move mountains and take orders. It doesn't do anything like that. It's a static website, but for an average small business that just wants to be able to put their phone number and things like that out there, talk about an easy way to be able to implement this. Really, really straightforward in doing so, right? So once again, we're looking at S3 and some of the easy capabilities it has in managing those tools out there and using this kind of stuff, right? Pretty cool process and extremely easy to build in using that. Nice. Now we're going to continue on with the demonstration. As I said, we have three major building blocks in working with an architecture. We looked at storage, and let me be clear, guys, there are a number of other storage tools out there. There's Glacier for archiving. There's Elastic Block Store for making the equivalent of a hard drive attached to a server. There are a number of services, but S3 is your most basic service that you'll be working with AWS. So let's move to computing power in using this. In your own data center, we're talking about having servers. Now, they could be physical servers, pretty much guaranteed, on which you may have virtual machines to use this. Once again, the responsibility of making sure that if anything fails, that we can make sure that it continues to run is fully on our shoulders. Or if we decided to offer a quick sale of some sort of flash sale, and all of a sudden we have 10 or 100 times the normal number of users accessing our website. Do we have capacity to handle that? And maybe we do. Maybe we purchased a ton of new hardware to be able to meet that demand. Great. What happens after the flash sale? You have a lot of unused, and still I had to pay for it, capacity for dealing with something like this. When I'm looking in AWS, the service that I'm going to be using is EC2, Elastic Compute Cloud. These are just virtual machines. But the big deal in using them is that the physical servers, they're there. They're in an AWS data center, but I pay if I use them. And if I turn them off, I stop paying for them. Once again, unlimited capacity. When I need another server, I launch another server. If today, for whatever weird reason, we went viral and I need 15 new servers, you can have them up and running in minutes. And when the day after tomorrow, when that viral boost kind of goes away, I turn off those servers and I'm no longer paying for that infrastructure and using this. So let's talk about this Elastic Compute Cloud, right? EC2. First of all, as I mentioned, they're virtual machines. And it's just that they're virtual machines that are running in AWS's infrastructure and doing so. You get to choose everything about them. The operating system, the hardware level. So you want Windows? No problem. You want Linux? No problem. Which version do you want? Hardware level? Do you want a dinky little processor that's pretty cheap? No problem. You want a massively powered processor with tons of RAM, tons of processors, and a GPU on top of that? No problem. We can handle that as well in using these. Once again, maybe I only need that massive processor for a few days, a few hours. No problem. Pay as you go. When you're finished, turn it off, stop paying for it. Even if it's maybe, well, what if I only use it from 9 in the morning till 5 in the afternoon? Turn it on from 9 to 5. When you turn it off, you stop paying for it. You want to reserve things, you can pay up to 75% less in doing so as well. If you say, hey, listen, I'll use it for up to a year or 3 years in doing something like this. There are big differences in doing that. Now, the additional features that we're looking at is the simple fact of what is known as horizontal scaling. You know, normally, if I have a server in my own architecture, right, in my own data center, if it needs to be more powerful, what I'm going to do is simply expand the power of that machine, meaning go ahead and give it additional capacity. So now the machine's this big. I'm increasing the amount of RAM, the size of the processor for that particular machine, but I still have exactly one machine using this. That type of change, generally speaking, also requires downtime because you have to shut it down, add some things in, etc. That's called vertical scaling, right? And that's kind of the old way of doing things. We are focused on horizontal scaling. This is really going to be that cloud native feature. The idea is, let's go ahead and put a little dividing line here. The idea is that with horizontal scaling, maybe I start off with the same server. But if I need more processing power, I just launch another one and another one and another one till it meets the demand, whatever it needs. And here's the benefit. When I don't need it anymore, I decrease the servers down to whatever I need to sustain to use this. Nice. Now, the drawback that some people say is, well, okay, but how do I distribute the traffic? Well, guess what? There are these things called elastic load balancers, which I guess unsurprisingly will balance the load between those multiple servers. This is a service that is built in, really easy to implement. I literally go into AWS and I say, I need an elastic load balancer. And there are a couple of different varieties that you can use. But the idea is I have a single point of contact for your average end user. So they're coming to my website or whatever it is. And all of a sudden, like I said, I get a lot more traffic. Tons of people are coming to access this. I launch 2 more servers. The people on the outside, they don't know anything about that. Instead, as new traffic starts to come through, the load balancer's job is to say, well, I'll just distribute it evenly across my servers and take care of it for you. All built in, all easy to implement. Now, disposable is not normally a feature most people would consider, but we treat our servers differently. When I started in IT, and I have close to 25 years of experience in IT, when I started in IT, every server was named after Star Wars or a Greek god or goddess or something like that. So, you know, if Yoda was having problems, you went and you fixed Yoda. That's just the way it was. In the cloud, we're going to treat them as disposable resources. To be blunt, if Yoda's having problems, you just terminate Yoda. And that sounds horrible. I get it. But I can launch a new Yoda in moments to replace it inside there. And in fact, I can automate the entire process so that it'll happen without any kind of human interaction as necessary to do so. Pretty powerful tool. So let's take a look at launching our EC2 instances and using these. We'll look at the launch wizard by choosing an operating system, a hardware level, and I'll even implement some user data here to be able to actually see how all this works in doing so, right? Again, powerful tool, but it does give us the ability to be able to see some of the different things that are available to us in using this. So once again, I'm going to go back into our AWS console. Bring this back up, but we're going to go to a different service. EC2 is listed right here, the first option under compute power in doing so. And once again, when I look at EC2 and I see some of the different options out here to use this, what am I getting? I just have the ability to launch a virtual machine very, very easily in doing so. Actually, let's do that first, right? Let's just go right through the wizard and then I'll walk you through exactly what I did as I use this. So I find launch instance, and I do so. A couple of different options. I'm going to choose my operating system here, and my operating system uses this. We're choosing Amazon Linux 2. I'll go through some examples of that in a moment. I choose my hardware level. Now, this is where you've got to understand that while I talk about the ease of building an architecture in AWS, it's not all completely simplistic. For example, if I need a web server, I have to tell it I need this to be a web server. Now, I'm going to paste in a simple little script. And what will happen is it's in this user data section, which is basically something that'll say when the machine launches, this is the script that I want you to run. I know it's running Linux. This is going to be something that will run. And really, it's going to say update Linux, install the Apache web server, and start the services inside there to be able to use this. And then when it finishes, I want to have a home page that says hello world that will pop up in there for me to use this. I am going to add in one more thing here. We have to open a firewall to allow port 80, HTTP, regular web server through. This is a good thing that we're forced to do this. Yes, it does add a slight bit of complexity to this, but the truth is I would never want this to be open to the public immediately unless I made that decision to do so, which I'm doing right here. Open up port 80 to everyone to use this. Review and launch, and I'll say, yeah, I acknowledge it, and I continue on to do so. That's the process. You just launched a server. That's it, right? And doing something like this, you go, well, okay, I mean, I like the benefit of that, and yes, this is an extremely simplistic server, but it's launching up here to do so. Immediately, I can see it's been given a public DNS address, a public IP address, all done. All simplistic, all super easy to be able to implement here, to be able to use something like this. Now, it is not going to be instantaneous that my website will come up here, right? And you can see if I refresh it, I'll see that it's running. It's still initializing, and it's also been about 20 seconds since I launched this thing. But if I go ahead and actually paste this inside here to be able to utilize this, right? Like I said, it is not instantaneous. This is normal. This is the other part that people forget about the cloud. Things are not instantaneous and perfect in working with something like this. It takes a minute or two to use this. Now, having said that, I literally mean a minute, right? Hello world now comes popping up. This is the website that we just launched in using this. Look, here's the IP address that we use inside. I put that into my server location. It says, sure. And it says, hello world. The fact that you can launch in such a short period of time without having paid for in advance any resources is insane. So easy to implement to be able to use this type of thing out there. When I use this, let's go through that wizard a little bit more slowly so we can understand everything that occurred inside. First, it says choose an operating system. Normally, you got to look at licensing. That's all built into the pricing here. So you choose whatever you want. Now, we do have the option of a number of different Linux varieties. Ubuntu, SUSE, Microsoft Windows Server. Okay, so we've got Server 2019. We got a number of varieties, but these are kind of the plain vanilla images with nothing else on them. They're up to date, but that's about it. Now you can create your own, and we also have this place called the AWS Marketplace. This is where you say, name a major vendor. They're gonna be here. And I don't just mean for, I need a particular application. I need a Splunk server. I need whatever out there. It's, you need a firewall? I can make that for you, right? You need a cloud services router? I can make that for you. You want a VPN solution? I can make that for you. You can do just about anything that's listed up here. Machine learning, Internet of Things. Look at all these different products out here and using them, right? You pick and choose one, and this is where they whatever you choose, let's say Juniper, has already configured a virtual machine that they will then charge you 55 cents an hour for the software to be able to run. Now picture that. I'd like to be able to try out a new firewall. Well, what if you could just launch it, try it, spend literally a few dollars. If you don't like it, you turn it off, you're done paying for it, period. You do like it, you can get a massive discount to pay for it by the year in advance in using something like that. This is where the AWS Marketplace comes into play to be able to see these. Get a number of different tools there. Now, again, when I go back to my quick start, I just chose the basic, right? Amazon Linux 2 in doing so. Now, my next portion would be to say, let me make sure I chose the right one. Yep, select. When I go through here, I'm now choosing the level of hardware. And of course, we're looking at the number of CPUs, the amount of memory, but it's also going to be about the type of storage, the speed of networking performance that we wish to pay for. And we're going to see that we have dozens and dozens and dozens of varieties of the different items out here. Like I said, I can even have ones that have GPU instances with massive 25 gigabit networking capabilities and using these. Obviously, solid state drives are available. I have all sorts of different choices within these to be able to use this. I'm only choosing the cheaper one because it's easier to be able to implement here. But you could choose whatever level you want. And if you don't like what you have, is there anything that says you can't turn it off and replace it with something new? Of course not. Go right ahead. That's exactly the point of the agility of the AWS cloud. Configuring instance details, next part of our little wizard here. I can go through and say, where do I want it to be? Which network? We'll cover that next, by the way. Do I want to be able to give it a public IP address? Do I want to set certain permissions on it? Who's allowed to do different tasks, such as shutting it down or turning it off, whatever I need to do to use these? Do I have that user data that I've specified? I can do all these different tasks. Do you need to add additional volumes to this machine? You can do so inside here. Tagging, one of the most important aspects in terms of security and management. It's simply a label that you place on it that I can then filter later on if I wanted to be able to see these. We mentioned the security groups. These are going to be built-in firewalls that we can generate. And then I go ahead and launch it. Now they do ask to make sure that you have a key pair. This is a way of actually securing remote access to one of these. I'm just using my existing key pair that's there. And I launch my instance. It's that easy. And I implement something like this to be able to get them running. Once again, I realize, yeah, I really don't want to pay for that web server anymore. I check the box, I go to actions, and I terminate that instance. Done, right? It's that simple. And specifically with Amazon Linux, I'm literally paying only by the second. So when I turn it down, I stop paying immediately. There are many operating systems where you pay by the hour. So even if I turn it off now, I paid the maybe 50 cents, maybe $1 for the full hour that I ran it for, but it's not exactly a big deal in terms of actually getting them working properly to be able to use that. Right? Powerful tool in using these. Those are EC2 instances, Elastic Compute Cloud. Our virtual machines are standard computing hardware, right, in the AWS cloud and using them. Our last building block is networking. When you build a network of any sort in AWS in your data center, routers, switches, cables, etc., and using these, you're going to be the one racking and stacking. And once again, you're responsible for high availability and capacity planning, because if something breaks, you better have redundancy. And generally that means you better buy 2 of everything, right? Including when you're talking about routers and switches and internet capabilities, etc. In the cloud, I'm not saying that things don't break. It is just running in an AWS data center. The difference is they are many times responsible for that redundancy and building it in and making sure that if something does fail, that something will come back up to be able to use these. You don't modify your router, you modify maybe a routing table to be able to do it. You don't even know that the switches, are they there? Of course, but you don't see them. Are there cables? Of course, but you don't manage them. They make it much, much easier to be able to take that responsibility off of our shoulders. In AWS, the service that we're going to be using is what is known as a virtual private cloud, or VPC. It is your private space in the cloud. Redundancy is built in, and it's just that, it's private. It is shared. You're in their data center with a lot of other people, with a lot of maybe even competitors. But of course, they guarantee your privacy to be able to make sure that other people have no access to your data, your servers, or anything in doing so. When I look at VPC basics, I'm talking about a network hosted in one of these AWS data centers. You just choose the region that you'd like to place it in to be able to do so, which is a very easy process. Now, as I've said, it is completely private, meaning it is not even directly accessible from the internet by default. You have to implement that. You would create an internet gateway if that's what you want. Otherwise, you'll have a direct VPN. You're going to have other ways of accessing it through the console, but no access from the public networks out there. And once again, to being said that it can be created in minutes, seconds in most cases. You go ahead and generate it, it's there, instant, in terms of working with something like this, where you have complete control over this and using that. Now, when I say complete control, can you still generate your own subnets? Of course. Maybe you want to subdivide different types of products out there. Some things that are public, meaning accessible to and from the internet. That could be a VPN server, a load balancer, maybe even a web server, or things that are completely private that I don't want touching the internet. Your databases and other tools in there. I can put them in the different type of subnets that I generate. Firewalls, remember those security groups? Security groups and these other tools called network access control lists are built-in virtual firewalls that you can implement to your heart's content with all sorts of rules and things along those lines. And then finally, can I have secure connectivity? It's in someone else's data center. How do I protect my access to it if we're needing regular access at all times? A VPN can encrypt the data, or there's another service called Direct Connect, with which you can use private fiber that goes from your office to AWS and never even touches the public internet to be able to manage these. Now, as I said, VPCs are relatively straightforward in working with these. So we'll build one. I'll actually set a firewall option inside there, and I'll actually show how to create a new subnet using a different location to be able to have higher availability in using these. Let's go back into our AWS console. And this time I'm going to go to VPC, the virtual private cloud, and dealing with this. Now, when I generate these, you will see that every region, and by the way, right up here at the top right, this is where you choose the region that you want. All right, so if I want, let's say I want to do this in Oregon. I click on Oregon. It will actually change my location in terms of using this, and boom, whatever I generate, whether it be an S3 bucket, whether it be a VPC or an EC2 instance, it will be launched in that Oregon location. Regardless of the region that I go to, there will already be a VPC there, a virtual private cloud there, because it generates one by default. It's automatic, it's there. It will always have this 172.31.0.0 IP address scheme. We can also create our own in using this. Create VPC. Now in doing this, there are two ways. I can go through this little simplistic way, or honestly, when I go to my VPC dashboard, there's a wizard here. Now check this out, launch VPC wizard. Because like I was dealing with companies in the past where they'll say, listen, Jeff, we're developers. We're really good at writing code and this, that, and the other, but we don't know where to be able to place these or how to implement this in AWS. They have these wizards like this. So what are you looking to do? And it will give you in relatively plain English what you're looking to do. Do you want a public subnet, public and private subnets? Do you want hardware VPN access? You pick and choose from these options on the side. So let's say I choose VPC with public and private subnets inside there. I'll just do a single public subnet. Hit select, choose my option. Range of IP addresses that you want to use. You can name it something. Test VPC, simple to use these. You're also going to go ahead and put in a single subnet. And this will be basically a subsection of this range of IP addressing and doing this. I can choose the availability zone that I want to place it into to be able to use this. See, what happens whenever you're setting up a network, we already chose Oregon inside. And so you're thinking, okay, I've put it in that region. Well, what happens in Oregon specifically in this case is it's actually subdivided into 4 different what are called availability zones. This means you take a region and then we'll literally regionally separate them. Within that region, we subdivide it into a number, a minimum of 2, a maximum of about 6 currently, different availability zones. Oregon happens to have 4. And they'll be listed as simple A, B, C, or D. By choosing one of these, I'm saying I'm choosing a different data center. Literally what I'm saying is at this point is that Oregon has a minimum of 4 different data centers, separate physical locations that AWS uses. And if I place some of my stuff in A and some of my stuff in B, even if all of A goes down, we have a power outage, something like that, they're guaranteeing that these are on different power grids. B will be up and running and it'll take over for me in using something like this. Oh, okay, so we've chosen that I want this availability zone to be in US West 2A. I'll name it public subnet 1. That's very exciting, right? And I say create VPC. It'll take a minute or two to be able to get this done. Oh, no, it's finished. They make it so easy to be able to implement something like this, right? Generates it so easily. Here's my test VPC and using something like this. Now, if I go down to subnets and working with that, right? And I can go through and I can specify the one that I want to look into or see the different subnets that are available here to be able to use this, right? I can pick and choose which VPC I'm working with or how to be able to set them up to be able to actually narrow them down. Now here I can see my test VPC. And if I want to create a new subnet, I certainly can, right? I'll name it public subnet 2. I specify the VPC I want it to go into. I choose a different availability zone in doing that. And I choose a different range. So maybe 10.0.1.0/16. I'm not going to do too much subnetting here to use this, but I create it. Oops. I have to actually have a range that it actually accepts in terms of using something like this. But I go through and I specify that inside to be able to do so, right? When I go through and I generate this, and I actually be able to actually make it work inside there to do so. Oh, I see why. It would be 10.1. Sorry, 10.1.0.0/16 and using this. Create that. Oh my gosh. Oh, I see what happened. So here's the problem. When using these, I set it up to actually have that portion internally to be able to use this, and it's not allowing me to be able to generate it to use this. But 10.1 or 10.0.2.0/24, that will make a lot more sense. Create it, and it generates it without mistakes. You make it very, very easy, and you actually go ahead and place them inside there to do so, to use this. So it generates a new subnet. It's in a completely different location, right? If I actually look at some of the capabilities, it'll tell me it's in a different availability zone and allows me to be able to find that very, very easily in doing that, right? Simple enough to be able to manage them, but wow, it's easy to do so. Now, I can name them public subnets, but unless I enter the routing table entries to be able to make this work, nothing happens. I mean, when I use something like this, if I generate something inside here and I look at the routes, I'm going to find that in this case, because I used a wizard, it created an internet gateway for me. If I don't route things properly, I don't get this to work. And all of a sudden people start saying, oh, the cloud's so complex. Guys, this is a lot easier than figuring out how to be able to manage a Cisco router out there, right? This is a really, really simple process, which I'm telling you, a 1-hour webinar probably shouldn't be relied upon to be able to do this. But could you build it on your own with a simple wizard? You could. Do you have the ability to have, for security, network access control lists and security groups, those virtual firewalls that I mentioned? Yes. Can you implement a virtual private gateway to have a VPN from wherever you happen to be into the AWS cloud? Absolutely you can in managing this, and allows you to set it up extremely easily to be able to use this inside. Now, when I use something like this to be able to generate these, and I actually work through all these, you start to realize that in less than an hour, I've shown you how to be able to generate all of the different pieces inside here, meaning the basics of storage, the basics of an EC2 instance, meaning a server, and even a full-on network, the equivalent of a full data center. Yes, a basic data center, but still the equivalent services required to be able to launch that in the cloud. Now, let me be clear. The services that are out there make this so easy to implement. That doesn't mean that you should rely on AWS to handle security and other tools. A lot of it is still your responsibility. There's a reason why they call these people cloud architects. We do the jobs that we do. It is easier from a hardware perspective. Planning is just as responsible on us. It's still our responsibility to be able to manage them. When we look at the different services available, I showed you the simple storage service, or S3. For computing power, Elastic Compute Cloud, or EC2. And for our network, our virtual private cloud, or VPC. As I said, these are the basic building blocks. That's it. We've just scratched the surface. When I say that there are hundreds of other services available from AWS, I'm not joking, right? When you actually go through and look at this little location inside here to be able to manage them, and we see all of the different services that are available here and using this, the sheer number of products, you start to look at this, you go, oh, there's quite a few. And then you realize when you click on one of these subsections, oh, each of them have their own subsection of products within this to do so. And I mean, it's not just computing power, augmented reality. Oh, okay, we can do that. The Internet of Things, you name it. Machine learning, big process right now in doing so to see these. So many different tools that they've made it easier to be able to implement, to be able to do that out there. Honestly, when I go through and use this and I see some of the different things that are available, it requires training. I'm not saying it's that simple. Global Knowledge is a great provider of this. And so again, you can use this out there to your heart's content. Good luck to you all. Good luck to you in using AWS. Enjoy your training, folks.